Welcome to today's LDC Institute, and we're very happy to have as our guest speaker today Bin Li, who's an associate professor at Nanjing Normal University, and the title of his talk is Construction and Analysis of the Chinese Abstract Meaning Representation Corpus. This is something that's not new to many of us here, so it'll be very interesting to hear Bin's experience doing Chinese AMR. To say Bin and his team in Nanjing are good friends of LDC. We've had a collaboration now over a couple of years. Bin has interests in computational semantics and ancient Chinese resources. So his ancient Chinese corpus, which is a POS tagged and segmented, texts of some of the very ancient Chinese resources from Warring States and Spring and Autumn, etc. He donated that to our catalog, and we're very happy to make that available. And that work he is continuing. Also, the Chinese AMR corpus was released by LDC this year, and he has also contributed Chinese Cogbank, which is a data set that we'll be releasing next year. Bin's an associate professor of linguistics in the School of Chinese Language and Literature at Nanjing, and he received his bachelor's, master's, and PhD degrees there. We're fortunate that he's in the U.S. now, and that's because he's a visiting scholar at the Institute for Quantitative Social Science at Harvard University. Please welcome Bin to LDC.
Oh, thank you. It's my honor to give a presentation here, and thank you for Denise's invitation, and thank you for Professor McLimberman. So the topic I got to present today is about the Chinese AMR corpus. If I have extra time, or I will introduce the other two resources we have built. This is maybe the new kind of semantic resource of Chinese and English and other languages. Is somewhat new. For traditionally, we only have the tree banks, and this is semantic bank, I think. And for my university, here we at the U.S., Philadelphia, and where is Nanjing? It's let's take a flight. Yeah, maybe. And we come to Asia, and this point near Shanghai. This is my new university. It's near the Yangtze River, and it's a very old campus. It is over 100 years, and at this time it is very beautiful. And welcome to our university if you have time. Yeah. Our group on Chinese language processing. My tutor, Professor Chen, he has retired now, but he created our group. And this is my colleagues, the Professor Xu. He's at the computer science school, and we collaborated many years. And I'm in the Department of Chinese Language and Literature. So my background is mainly the corpus linguistics. So we are busy with the corpus, like here, I think. Yeah, language resources. So we built Chinese corpus, like the Asian Chinese corpus, the Cogbank. The Cogbank means something cognitively related topics, like is a bird nice? Is a monkey smart? Is flower red? We collected such information from Chinese texts. And of course the AMR. And we also do some quantitative studies on the corpus for the Chinese language evolution and metaphor computation and AMR parser. And we also do some research on the ancient Chinese lexical parser for the names, named entities, for the word segmentation and sentence segmentation together. And the last part is digital humanity. We also do some work on the ancient Chinese histories. We want to put history into database. That's really hard work, and that's why here in Harvard. Yeah, that's for the Chinese history part. We also have some cooperation with Bert from Brandeis University, where I started to do the work on AMR. And this is my tutor at Harvard University. He's 中国通. He knows everything about China, I think. This is a corpus we submit to LDC. It's Asian Chinese corpus, and the Chinese AMR. If we have time, I'll come back to the Cog Bank. It's like this. Something interesting. For today, for the AMR part, I want to discuss such things like what is AMR, how we made the guidelines for AMR. Because English has already done this before, we want to annotate the Chinese data. How can we use the AMR, the English AMR guidelines to Chinese? And how we construct the corpus, and what we found based on the data. So basically, the questions is AMR tries to give a semantic representation of the sentence. So why we need this? Why we need the graph structure? Why we need it semantically? And if semantically we abstract the words to concept, could we trace them back from concept to words again? So this is a crucial question. And is AMR universal? Can it be a meta language for all languages? We want to answer such questions. So the first thing is, what is AMR? So I want to start from the tree bank style. This is a syntactic tree style. There are two. Always, they have a great context for each other. One is Chomsky's theory, one is dependency grammar. It's Tasniye's style. So in this way, we know in CDB, in tree bank, it's something like this. I trimmed off the pro or something else. For the sentence like, he wants to eat the apple. Well, people always find that wants to eat the apple. Who is the subject for it? May say there's no, because the subject for want is he, and who it? Who it? Everyone ate here, so so who it? For the computer science, many scholars say, oh, why not? It's simple. He eats, but many linguistics would not agree. But in practical, most of us want to say, yeah, he eats the apple. So this is the dependency style, and we just represent the relations between words like subject, object, or some modifiers, or this determiner, and in this way, that's something bad, because in dependency structure we have to re-annotate this twice, because its subject is here, and this is only because we have the trace structure. If we add this relation to the tree, we get a graph. So to make it clear, in FrameNet, they do such things. They would say, he is argument both for want and it. So he has two semantic rows. But they would try to annotate this twice. So in AMR, people say, why not give to show it like this? It's simpler, and that takes a want as a root. And he is the argument 0. This means agent, who or subject, and this is object, or the want what and it what. So this is or argument 1, and argument 1 is more simpler for the very complicated things like this. There are so many semantic relations. So for AMR, they want to simplify it. And for the argument sharing, they just put it and he. There is a link, argument 0, he, its. So in this way, it is very clear and easier to understand. It's only a graph. Technically, it's called a rooted, directed, acyclic graph. Yeah. In this way, it's clear. You don't have to do it like this, and you don't have to do it twice. So this is AMR. They want to do more. For example, the example is here, but we can see that he wants to eat apple. What's left? And the S2, the is gone, right? And so this is what they call abstraction. They just abstract the concrete the concepts to the graph. Anything else will be trimmed off. Yeah. So they think it is easier. And when we put it to Chinese, wow, it is very good, because in Chinese we don't have the S, we don't have to, we don't have zig. So in this way, we always have the bare nouns, the bare verb. We don't have inflections. So when I say AMR, I say, wow, it will work on Chinese. So we started to do this. And AMR also supplies new ways to overcome the problems of tree bank. Something like this: the dancer has gone. The dancer has gone. They would say the dancer have to analyze this. They just put dance and ER separately, and the ER is person, is a person who dance, and the person gone. So in this way, it becomes clear. And especially for the sentence like the young has gone. The young has gone, you would say, young gone. That's wrong. So they would put a person here. And the person who is young has gone. So they supply some tricks of add some concept or delete some concepts when needed, according to the context. Yeah. So we like it. Yeah. Because in China there are a very special construction we have to handle, because it is so common. It does not in the English. It's like this: dance. This means off, go away. And we can say it, go away. Or like this. And who will be the person who dance, who eats? And in AMR, we can add this person back. It's easier to understand. It's easier for the computer to process. If we do it like the tree bank way, well, that's a disaster. We will take a dance or it as an actor. That's terrible. So so that's why I like AMR. It can add something back. So in this way, we know what is AMR, and the graph is really better. It can solve the argument sharing, and it can add something back. So the other questions we will continue is the AMR has some problems. It's really hard to automatically parse AMR graph. In the bake-offs before these 2 years, the best result is only 64%. It is very low compared to the trip-hank parser. And now it's better. It's about 74% when the neural network is applied and pre-training used is better. But it's still hard. Yeah. And the second problem is a alignment problem. The alignment, you see, what is alignment? Let's go back. We can see that there is no alignment between the concept and the word. They just give the things like this, and the dancer is separated. How could the computer know these two concepts correspond to the one? So this is the crazy part of it. Yeah. So for the parser, if you want to train an AMR parser on the English corpus, you have to train an alignment parser. You have to alignment the word and concept to align them, and the automatic way is only about 90%. Yeah, so that's no good for the parser. So when we want to build the Chinese corpus, we want to change it. We have to add the alignment back. So this is status of it's about 3 years ago when we started. Yeah, there is only the English AMR corpus, and we test some translation of the Little Prince. No, every AMR corpus has Little Prince. We just annotate some Chinese translation of it. And we also want to get this part. So where did the functional words go? They just be trimmed off. Is this useful, or do we miss something? So we want to add this back, and want to add the discourse relations back. Because AMR don't focus on it. There is no clause relations. So we add this to the AMR, but not only we follow the English AMR's guidelines and specifications, we are making sure that our data can be the same. If they want, we can give them the format exactly the same as the English AMR did, and we just add something new here. You can take it as a different layer. Yeah. And this is the first part we add for the alignment. For this sentence is a Chinese sentence, means who help. This is complicated. This is a wrong character sometimes. Such big of business, and simply it's just me who helped me so much. Yeah, and in Chinese, that's a crazy part of it. As help business is only one word. One word. So there are many words can be used separately and combined. And in our mind, we always think this word is only a word. It could be used separately, but it's a word. For the English AMR, they do not treat something like this. For us, we just combine it together. But for English, that's a crazy part, I think. For example, put on. Put on, they just trim on. Only the put is there. So I think it's wrong. Yeah. So their corpus still have this issue. So we combine them together, and this is who is translated to AMR unknown. Who can help me? And here is me, and this is how big, such big, and the sentence is interactive. And when training an AMR parser, some programmers have to add this back. Oh, this help. This help is aligned to the second word, and who is aligned to the first word. So they do the alignment automatically, and there are some errors. So when we begin to annotate Chinese text, we do it like this. Why not just put this as its index? And here they just x1, x2, x3, x4. That's no use at all, right? Why not like this? x2 and x8 together? That's help. And x3 is this word, and x1 is unknown, x4 is me. So we just use the index of each word to be the index of the concept. So it's very, I think it's very simple, yeah, to make the alignment. So I asked them many times, why don't they do this simple trick? Yeah. And they are busy with alignment. Yeah. Okay.
This is not shout too loud. The AMR corporate that we worked on and released, so LDC hasn't produced this layer, but ISI would also produce an alignment layer that would go along with the corporate. And I don't know if you made use of that or found it to be insufficient for what you were trying to get out of the data.
Yeah. So that's another layer. So why not put them together? So I don't know. Yeah. So in this way, we also can treat this if there is untapable arrow. Yeah, it could be easily be covered by this metric. This trick is x4. Yeah, it's x4. It's here. Although it's written like this, and when we linked, we know this is the correct form. So in this way, we can treat all the type arrows. In this way. And also for like the downsert before, the Chinese has the same thing, like the processor. Yeah. How to treat it? So we just use this thing to add the sub-word index, because this character is the third one. So we use x2, the second word, the third character. Yeah. So it's here. This is this thing. So in this way, we can align everything. For the combiner or splits. Yeah. And the more difficult part is the relation alignment. This part is completely gone in English AMR corpus like this. The goal wants to study at Philadelphia. Is goal want at Philadelphia study, and this word at at. This at means location, and it's trimmed off in AMR corpus because it is not a concept. It's only a preposition. So all preposition is trimmed off. And we don't want to trim it off. So we put it at the relation. Like this, we add something here. So location is represented by at. We use this way. So almost every word got to be on the graph, not just the concrete words. So in this way, we think we may find the semantic graph, not semantic graph. It's just a graph for the sentence, for the whole meaning. So after we annotate this information, we could know the functions of each proposition, and later we will show that. And in another way, we also know that each relation is represented by what words. Sometimes it's a concrete word, like a verb, and sometimes it's only preposition. So we think this is very important. So we add concept and relation alignment to it. And we also add some other relations like tense aspect, classifiers, and perspective. And we know that in China there is no tense at all, but we want to put the words like this, will, as tense. Also, there are many words for aspects. We all annotate them on the graph. And this is for the classifier, the very special phenomena in China comparing to English. In English, we only say a house, but in China, you have to say maybe a set of house. Yeah, we often say this. And in the MRA, oh, this means nothing. We have to trim it off. Yeah, but we are Chinese, so when we annotate, so this gone, okay, we want to add this back. Yeah, and I think it will be useful when build machine translation systems. You can know, oh, where it is. It's here. It is a classifier. And we also add the relations of interclause. Yeah, we add this and or concession, progression, temporal, like this. And in the English AMR don't have such things, I think. And now the Brandeis University is also building the UMR. They want to add this temporal, this kind of relations to the English corpus. And we say we already have this. Yeah. So this is a crazy but real example from the data. Yeah. We may say that this is one predicate, this is another, and they are combined by causation. Causation is and its argument one means this is cause, this is the result, and in this way the structure of the sentence is more clear. And we also made some specifications for Chinese phenomena, like this two we have mentioned before, like a split structure or the argument sharing. And we see this. This is a contribution of AMR, not our contribution. I think it's Kevin Knight's. Yeah. like the nian nian, this phenomena is what? It's like this, nian nian. It means year, and in Chinese it means every year. So in tree bank, you only put this as something redundant. Yeah, it's making nonsense. But in AMR, it's every year. The meaning is changed. So in this way, we have this real example from the Corpus. It's like the conference is held every spring, every year. So in this way, we put it in the frequency is every year. So this is read entity 91. So in this structure, put forward by the English AMR, we can give a good representation of Chinese. This is really good. And in this way, we also can treat the phenomena like say means say, not every say. So the Chinese is somewhat different from English. And dry clean means clean. So we can combine this to one concept. So AMR supplies a very good trick for this. And this is something we mentioned before. And this part, I like it very much because in the tree bank, you cannot handle this. For example, go not complete. Go not complete. What does it mean? It means not possible to go. You can't go. It means this. So that's crazy. And in AMR way, we can annotate it. We can represent it right, not wrong. And there are something like this. He sing, cry, complete audience. What does this mean? He sings, causing the audience to cry. So in AMR, it's easier because we can use cause, the concept, to combine the two predicate. In this way, it's really awesome. So after we annotated the Little Prince, it's only about 1,500 sentences. We want to treat it seriously. So we take 1,000 of 10,000 sentences from the Chinese tree bank, the S version, and we use predicate frames from the proper bank. In this way, we built the corpus and we share to LDC. And the most difficult part is this, the inter-agreement. For AMR, it's really complicated. We have to train a graduate for about half a year to do this, and not always successful. For example, I trained more than 10 students to do this, but now there are only 4 left because some are getting crazy. I said, wow, this is too complicated, and I give up. So this is a predicate dictionary we use. This is for the sentence like before. The English way is, you see, want has many arguments in the dictionary, and this is in the Chinese proper bank. The dictionary is like this. It has 3 meanings or 3 senses, and each sense has 2 arguments. That's simple. We just use this to do the work. But nowadays, people are getting tired of this sense because they all have 2 arguments. Why don't you combine them together as one? Because to construct such dictionaries, it's a waste of money and time. Yeah, we always met some new words, and there is no frames can be found in the dictionary. So how could we add something to the dictionary? That's really hard part. Yeah, and I discussed with many guys, and mostly in the CS department, they always say, oh, it's not necessary, just trim them off. Just say argument 0 and 1. Don't bother the senses. Don't bother. And my background is linguistics, and I dare not do this. So it's always a debate like this. Yeah. If you want to do something faster, you have to leave something out. This is abstract concept we used from the AMR, the English AMR, and this part is we added up. So you see how many concepts? More than 100. So the students will be crazy. They have to memorize all of them. Yeah. And for the semantic relations, yes, these 5 we added, and the others are still so many. So many. So I don't want to bother the details. And now it comes to our analysis of the data. What can we find from that data? So let's see the graphs. First thing is graphs. So is graph useful? We say that not that useful. This is the English part. It's about 10,000 sentences. And our Chinese is about 10,000 sentences. So it's the same scale. So for the comparison, we see that the sentences having graph, not just a tree, but a graph. It has actual ages. So average sin is 49%. So how to say? Half of the sentence are just trees. So that's why Chomsky's theory is right. Yeah, so still a tree, and we found the same on the Chinese part. It's 47 or 48. It's quite close. Yeah. But we found when we consider the sentence length, how many words sentence have, that's a different story. Because we can see that when the sentence become longer, about 20 words, it will become a graph. And when it become longer, it will totally be a graph. Because there are so many predicates, their argument would be shared by some nouns. So we can see that the traditional traits are here. It's here when the sentences are short. So that's true because theoretically in the textbook, all the examples are quite short. So they would not pay much attention to the long sentences. So when the sentence is getting longer, they are all graphs. And we get something else, like how many re-entries do we have, and how many, let's see, like this. How many words per sentence is 22? So long sentences are quite common. And how many concepts? Only 19. So 3 words are functional. So how many semantic relations are there? 22. It's almost the same. So it means there are some re-entries. So there are about 2 of them. And between the 19 concepts, there are, concept per sentence. The concrete concept means we have to add some concept, like person, like and. So we add about 3 concepts per sentence. Yeah. And here is a ratio of the words aligned to relations. So this is the English MR Dundle. It's quite a lot. So the functional words can be linked to the relations. Okay.
So, is there any similar statistics from the English AMR corpus?
Not yet, because I think they can have half of this table be filled, because the others there is no alignment.
So yeah, I'm interested to know whether there were any re-entrance per sentence, abstract concept added, so whether there were any language variations.
Yeah. That's good. We'll do it later. And I think. So here is the relations marked by the prepositions for the location is at, and source maybe at, time maybe at. So in this way, we know the functions of the functional words. Yeah. Why they are called functional words? Now we know much better, I think. And the last part of the analysis I want to focus is for the non-projective traits. It is not well studied in the Chinese corpus, because in Chomsky's theory, there is no such things. It's all handled by the movement. It's all the story in the dependency graph. You can see this sentence, a hearing is scheduled on the issue today. The hearing is on the issue today. So when we add this dependency relation, the H's come to cross. You get crossed, which is actually, that's bad. That's bad. And this is the ratio in the Chinese AMR corpus. About 30% of the sentences have this phenomenon. So this is quite, I think, quite a small part of the language theory. Not many linguistics get interested in, but I think this is very important principle of the sentence structure. So when Chesnier, many years ago, and his followers in America, they all put forward a basic principle for the dependency grammar that is projective. All the relations cannot be crossed. In other words, this is a word order. It's I like the apple, and their dependency should be like this, no cross. If there is clause, the sentence is ungrammatical. But things get changed, so when they constructed the Prague Bank using the dependency grammar, more and more cross a font in the Czech. It's about 23% of all the sentences have the cross H. So his PhD students pay much more attention to this, and in other languages, the dependency tree bank, I think, the ratios of the non-projective sentences are getting higher and higher. Mostly, their basic conclusion is when the language is more free on the word order, it would be like this. Yeah. And about 10 years ago, McDonald's, the Hamburg, they developed the dependency parsing for non-projective sentences. Yeah, they have to add some tricks. And there are more statistics or analysis on some other languages, and this is zero is only because the data that he used in the previous slides we can see Spanish is not zero, but there is non-Chinese corpus before pay attention to such phenomena, and all the dependency corpus of Chinese followed the projective principle, so they would not annotate a sentence like non-projective, so they are ruled out. So years before, I want to know the non-projective ratio in Chinese, and I want to study this kind of phenomena, but there is no data. And for AMR, I got this chance, so I found this real example here. It is the live bear take gallbladder. Say something like this. Yeah, they more. If there is no cross, you should say take the live bear's gallbladder. But the sentence is like this. There are so many natural sentences like this. It's really get crossed. Yeah, and something like this. In English, I think the same. Yeah, because I think if it is in the middle of two clauses, it will cause cross. Yeah, because I think must be the highest, the root for the sentence, and the others is this condition, so there must be some crosses. And okay, this is for the separate word. So we found this ratio, and we found the real examples. So we are very happy about this for the linguistic background guy. Yeah. I think this simple or complex, this kind of representation, I think it's better. And complex or not, that doesn't matter, because computer can treat it well. And I think there is a great line for the linguistic theory to develop. It's from projective trait to non-projective trait, and to graph and to AMR. Why from graph to AMR? Because here nowadays there are graph bank, so many graph bank, but they do not add or delete the concept. So AMR supply the trick to add concepts. So we are working on this, how to make the story theoretically. Yeah. At least I think it's a very good or better representation for Chinese. Yeah. All the other theoretical metrics or computational ways is not so good. Yeah, we found it. And why some of my students insisted, they insisted, they find that this is really good, And we are also doing some parsing work for the Chinese, collaborate with Professor Xue and ourselves. It's about 60 now, only on the 10,000 sentences. I think the more data is on the way. I think we have 30,000 now, but they are still under the check. We have to check the errors because there are so much data. For the English, it's getting better because the English has 60 for the training. 60,000 for training sentences. So their F-score is better. I think that's natural. So here is the conclusion. Why I think I can answer these questions. Why graphs? I think at least the argument sharing needed. Could the concept be aligned? Yes, we do it. And is AMR universal? I think it could be possible to develop AMR corpus for many languages, for all the languages, but it is not an interlanguage. Yeah, it's not that that's possible because we have annotated the Little Prince, and there is English version and Spanish version. And when we compare them, we find the predicate, the concept are different. It's not because the structure is different. The concept is different, and you cannot translate from them. And the structure would be totally different because of the predicate, because their frames will be quite different. So this is okay. And something new, I think the alignment gives us on the functional words and the non-projective, I think is the best thing I love. So I think there is something more. I think this is a very interesting one, because you can say his high school teacher is younger than mine. I think there's something like this. But for comparison, it's only the high school teacher like this. And it's quite difficult for us to say what is the comparison. At the beginning, we just want to say the teacher, this node, this concept is a comparison part of it. And if this is only used, we say, oh, where is high school? A high school should be used. Like if we put this subtree, oh, that's a disaster because he's comes here. So this is only part of a subtree. That's crazy. Part of subtree. So this is a problem for dependency structure because there are two layers here, two layers. So when we talk about this, we always get curious how to handle this, because dependency structure do not have the good layers as a Chomsky style. So there's other things we do, but I think there is no such time. And we got do is for discourse. We want to upgrade our sentence level AMR to paragraph. Some paragraph, the full news, or some dialogues. 3 of my students are working on it, and we want to add the inter-sentence relations and co-reference, and other relations between the sentences. So we want to give a full representation of news or story like that. It's really difficult one. And on the other hand, we also do dialogue. It's really hard too. My students has tried more on this one, and we find that ellipsis and co-reference is really crazy, because ellipsis is so many. You cannot avoid them, because our is completely gone. Just say a verb and an object. And in many cases, just some verbs. Yeah. And we are also trying to find some data to annotate without the copyright issues. Yeah, that's really a big problem. And I think this is last thing for the constructions. Is really hard for any linguistic series like this. Jack Long and Tom Short. What does that mean? That means criticize. Tom and Jack. Gossip. Gossip. Yeah. So that's a better translation. So we try this. Let's try if AMR can do this. So this is a small corpus, only about 1,000 constructions. A very small sentence, very short. And my students annotate them all. So about 60% of them can be represented. And 40% cannot be done. Because this is like idioms, and phrases, or the expressions, For this part, the compositional way to represent the meaning fails. So we have to do something better. Hopefully, this kind of expressions does not occupy often.
So for this actually also applies to English, because English has a lot of idiomatic expressions as well, like a kick the bucket.
Yes,
right?
yes.
So it's a challenge for a lot of languages.
So we are trying to make this work. So this is our team. Some of them are my students, and some are professors. So in the future, we want to refine the guidelines and get a better theory for the semantic representation. Maybe not just a semantic. I think for the functional words, we have to treat them equally. So just a theory of representation of sentence structure. And we are going to annotate more data. And I hope we can release them from LDC. And we have to develop better dictionary and AMR parser. So that's mine. All of it. And hope you can give me a call, give us some advice on how to do this hard work.
We have time for some questions. If anyone has any questions for Bin.
You haven't mentioned about the tool that you use to do the annotation.
Okay.
Could you say something about that?
Okay. If you want to see it, I can show it online. But maybe it'll take some time for me to find it. Maybe there are some other questions.
I have just a quick comment. So you mentioned that you're looking for some Chinese dialogue data.
Yeah.
I wonder if you've taken a look at the Bolt Chinese SMS chat corpus that's in LDC's catalog. So this is text messages. It's natural data, and could be quite interesting for AMR. I think that might be worth taking a look at.
Yeah. Thank you.
Yeah, we talked about that last night a little bit. We were looking at like Call Home, and we were looking at Bolt. So I think we do have some data that could be useful for this work.
Yeah, this is the page for annotation. We just like the command. You just put something in, and this is for the frame. You can add them.
Developed by your place?
Yeah, I wrote it. Okay. Okay. Because it's really hard for me to find some CS guy to do this, because I have to test them, and if I find him, he will be get annoyed. Oh, you have to change that, change that, change. So why not? I write it myself.
Related to Shunsung's question, did you make any use of ISI's AMR editor?
Yeah.
You did.
I used it before, but because we use the index to do the alignment, so
I see.
So we have to rebuild it.
Yeah, the ISI editor does references to concepts by these variable names, and so you can still, I guess, handle that.
Yes,
okay.
yes, I use that. They especially they create an account for me. I tried.
Okay.
I tried the Little Prince myself. All the 1,000 sentences I input them.
I had one more comment real quick about the cross sentence stuff that you've been working on. we did a small pilot annotation effort on multi-sentence AMR. It was English data. And that's in the next iteration of the AMR corpus. And it's not on dialogue data. It's, I think, on a mixture of web and news data, but that will have some probably relevance to some of the problems you're looking at. It's a combination of identity chains, so identity co-reference across sentences, and then there's some set-subset relationships. And we also co-referenced implicit variable, or did implicit variable co-reference, which is an interesting problem that comes up. We also ran into the question, you mentioned the scope of the cross-sentence work might be paragraph level. And so we found that with really long documents, you started to go crazy because you can make all sorts of bridging relationships. And,
we have this problem.
Yeah, we scoped it to just, I think, a certain number of sentences back to just be able to manage the cognitive load. And it's an imperfect solution, but it's a difficult problem. So
I tried to design the toolkit, but failed because of so many sentences. And AMR graph is so large. And this is Chinese AMR webpage at Brandeis. It's sometimes updated. And if there are some time left, I would like to share something.
Yeah, go ahead. We have a few minutes. Yes, that's fine.
This is for the Chinese history. 5 years before, we only can do the full text retrieval of the text. And now we annotate each person and each place on the map. So now we can find someone. Now we just the most famous thing, the guy I think is Qin Shi Huang, the first empire of China, and in this way we can see where he traveled, maybe. Uh-oh, it's still jumping. Okay. So it is famous history book of Shiji. So we put everything in, and the people and the places. Now we know these places, and especially this one. If you come from China, you may want to know this one. 东临碣石以观沧海. Where is 碣石? It's here. It's here. And then we know, he probably has gone there and many places. So in this way, the history would be on the map. And we know, where are the people and where are the things. So this is the Asian part. And for the cognitive part is something like, oh no, it's false. This is wrong because it's not my computer. Okay, this may take time. I just show the online version. This is English. Maybe you know. It's something like this. The pig is great, is fat, is magnet. But this kind of thing is already done by some professor in Ireland. And what I'm doing is for the Chinese part. So we can know that it's the same thing. It's pig. You can know what is pig. And it is like this. And it has more properties. For the pig as ignorant, it's very dirty, and it's very greedy and very stupid. We know something like this. So it is a cognitive knowledge base of Mandarin Chinese. And in this way, you can know some idioms from it. Why people I call stupid. And I think this may be useful for the Chinese learners, for the foreigners, when they want to say somebody is stupid. what can I say? Stupid like this. Stupid, and you may know there are such things are stupid, and you can use it to describe anybody you want. Yeah. So this may be useful for the poem, for the literature understanding automatically. Yeah. So
you do like the line between to connect the.
yeah, the line means strength. And this animal, this is the pig.
So
yeah.
you pick pig to describe somebody that is stupid.
Yeah.
Okay.
That's unfortunate because they're actually very smart.
Yeah.
In China.
Yeah. The pig is smart too. Yeah, you can see he has many properties, and but stupid is more than smart. Yeah. Yeah, culture related. Yeah. So I think that's all I want to introduce. Okay.
Anything else for Ben? Thanks
Maybe.
very much, Ben.
Yeah. Thank you. This is for winter. Yeah. Thank you.